Oh, give thanks to the Lord, for he is good. His mercy endures forever. Welcome back, friends, to Faith Matters with Phillip Campbell, a Catholic variety program broadcasting on Good Shepherd Catholic Radio out here in lovely Jackson, Michigan. I am Phillip Campbell, your host and traveling companion for the next half hour, and I'm very pleased that you are tuning in today to the Faith Matters program. You know, I take a very lively interest in the contemporary debates between atheists and theists about whether the contemporary state of science supports a theistic view of the world. It's just a very interesting subject for me to follow, and as a Christian, very relevant. Back in 2014, a few years ago, the Wall Street Journal, of all places, columnist Eric Metaxas published an interesting piece titled "Science Increasingly Makes the Case for God." This article argued that recent scientific discoveries about the universe actually increase the likelihood that the cosmos is the result of an intelligent designer. Though this article by Eric Metaxas is brief, I do recommend, if you can find it, to do a studious reading of it, as it brings to the fore several very, I think, essential problems with viewing the universe through a purely materialist lens. Now, in today's program, what I want to do is try to examine the issue of probability, which Metaxas talks quite a bit about in this article, and the concept of something being statistically impossible, and how it undermines the materialist assumptions that, given enough time, anything is possible. So let's talk a little bit about the idea of life and the parameters necessary for supporting life. The Metaxas article centers on the question of the conditions necessary for life to emerge. In other words, what core ingredients, biologically, chemically, are necessary to support the existence of life. Now, one of the more traditional arguments against God's existence goes like this, that God was only invoked by primitive human beings as a means of explaining phenomenon whose causes remained obscure. But as the age of science progressed and we learned more about the natural world, it increasingly became less necessary to invoke a creator to explain physical phenomenon, right? Primitive man sees the lightning and he goes, "Oh, it's the lightning god doing it." And then later we understand what causes lightning, and so we no longer need the lightning god to explain it. And as knowledge progresses, eventually every mystery about the universe will be explained this way, and one day theist explanations for the universe, religious belief in general, will wither away altogether as scientific discovery displaces it. This is what we might call a God of the gaps argument, that we attribute what we understand to natural causes, but when natural causes are unknown, we invoke the action of a God to fill in the gaps in our knowledge. And as we learn more over time, these gaps will grow smaller and smaller until God becomes unnecessary and belief vanishes. Now, in my opinion, this argument is very flawed in that it misunderstands the fundamental religious impulse of man, but we could also flip this argument back around on the atheist. If it's alleged that God is invoked to explain natural phenomenon whose causes remain unknown, it could equally be argued that natural explanations are invoked to explain developments that are simply not possible if we're assuming that matter is all that exists. For example, the jump from non-being to being, or the jump from non-life to life, which are the two most fundamental leaps in the development of the universe. The leap from non-existence to existence, and the leap from non-life to life. And can these, what John Paul II called ontological leaps, be explained by merely materialist assumptions? Eric Metaxas' article deals with the second issue, the transition from non-living matter to living beings, and whether science can offer any convincing explanation for it. Now, it was assumed back in the 1960s and 70s that life would naturally emerge when the right material ingredients were mixed together. The prevailing model of this was like a chemical soup. You mix all the right chemical ingredients together, and once you get the right ingredients, life emerges. In 1966, the famous author and agnostic cosmologist Carl Sagan argued that really only two essential ingredients were needed to create the conditions conducive for life. He said the right kind of star and a planet located at the proper distance from that star. Now, given what was then known about the universe, this criterion of Carl Sagan should have made the eventual discovery of other life in the universe very probable. Now, to quote the Metaxas article, he says, quote, "Given the roughly octillion planets in the universe," now that's a 1 followed by 27 zeros, "there should have been about a septillion planets capable of supporting life." That's a 1 followed by 24 zeros. With such spectacular odds, the search for extraterrestrial intelligence, SETI, a large, expensive collection of private and publicly funded projects launched in the 60s, was sure to turn up something soon. End quote. So those are pretty good odds. Based on Carl Sagan's analysis, there should have been a septillion planets in the universe that were capable of supporting life. So life should be flourishing all over the universe. But as we came to learn more about the universe and about the miracle of life, science realized that the necessary components of life were not that simple. Carl Sagan's original estimate of 2 necessary conditions was eventually raised to 10, and then a later revision in light of further discoveries stated there were 20 necessary conditions. By the turn of the 21st century, scientific advances had now set the number of necessary conditions for life at around 50, which of course, as you increase all of these necessary conditions that all need to be present in the right measure and the right mixture, this drastically reduces the amount of potentially life-supporting planets in the universe. In 1966, we had 1 septillion potentially life-supporting planets, but by the year 2000, this estimate had been reduced to maybe a few thousand. And with each new discovery about the universe or biological life, these numbers were constantly being revised, further raising the number of conditions and reducing the amount of planets capable of generating life. Now, by 2006, the estimates of the necessary condition for life had risen so high that a representative of the SETI project, which is the Search for Extraterrestrial Intelligence, wrote an article in the Skeptical Inquirer magazine basically admitting that all earlier estimates of statistical likelihood of finding life on other planets, quote, "may no longer be tenable," and that expectations about finding a planet that could support or generate life may have to be put to rest. In fact, as further conditions for supporting life continued to be discovered, the mathematical probability of there being any planets able to support life began approaching 0. The odds were tremendously against any planet supporting life, and this is what's most astonishing. Even this planet, the odds of this planet supporting life statistically approach 0. Today, the list of parameters necessary to support life is around 200, and will probably keep growing in the future. As Metaxas says in his article, the odds against life in the universe are simply astonishing. Now, I'm going to talk a little bit about statistics here. We're going to talk about some math. I promise I won't. I shouldn't promise I won't bore you. I shall say I promise I will not endeavor to bore you. But statistics is the study of data, usually for the purpose of determining the probability of an event or a condition. A probability is the likelihood that something will occur, usually expressed in mathematical terms. Calculating probabilities is governed by certain mathematical principles. For example, let's say we have 3 cups on the table, and only 1 cup has a ball beneath it. The probability of someone choosing the cup with the ball on their first pick is about 1 out of 3. Because there is only 1 right or desired outcome in this event, and 3 possibilities. So you have 1 outcome, 3 possibilities, so there's a 1 in 3 chance. Very simple. But probability gets more complicated when the one outcome you are studying has to have multiple factors all arranged in order to bring it about. So let's do a little mathematical thought experiment. Suppose I have 6 blocks in front of me, and each one has a different number. Okay? 6 blocks with a different number. What is the likelihood of choosing any one number? Okay, that's easy, 1 out of 6, right? But suppose we want to know the likelihood of throwing the 6 blocks and getting a specific sequence of numbers, say 6, 1, 2, 5, 4, 3. I want to roll the blocks and get them in that order. How do we determine the probability of throwing the 6 blocks and getting that particular order? To calculate this, we use a mathematical function called a factorial. Don't change the channel. I won't get too much into the math, I promise, but this is important to get. Now, the factorial function is used to figure out the number of combinations that we can get from any set of objects. So in the thought experiment we're doing with the 6 blocks, we need to know the probability of getting one particular sequence. But to know this, we first need to know how many possible sequences there could be. So to do this, we use the factorial calculation. And the way we do this is if we have 6 blocks, we multiply 6 times 5 times 4 times 3 times 2 times 1. If you wanted to write this shorthand, by the way, the symbol for factorial is the exclamation point. So 6 factorial is 6 exclamation point. Now, the answer to this is 720, which means that there is a 1 in 720 chance of randomly throwing the sequence 6, 1, 2, 5, 4, 3 on the first try. Or to say it another way, those 6 blocks, you would have to throw them 720 times on average before getting the desired sequence. Now, obviously, the odds against something rise dramatically when the number of variables required to come together are greater, and even tiny increases in this can affect the probability drastically. For example, the factorial of 6 is 720, but the factorial of 10 is 3.6 million. So it's about 3.6 million times more unlikely to get a particular combination of 10 blocks than it is to get one of 6 blocks. Okay, now I know what you're thinking. You're saying, look, just because something has a low probability doesn't mean you're going to have to completely exhaust the entire realm of possibility to get that outcome. The odds of winning the Mega Millions jackpot are 1 in 259 million. But in fact, somebody does win it almost every time. The odds of being struck by lightning twice in a row in your life and surviving are extremely low, but this has happened to people. So, the fact that a probability is remote or small doesn't mean that something cannot happen, only that it's less likely to happen. There's a very low probability that I will be hit from debris falling from an airplane, but such things have happened to people. In most cases, as long as probability exists at all, the chance of an event occurring cannot be ruled out entirely. Now, you notice I said in most cases, because there are certain situations in statistics where this is not the case. These are what we call cases of statistical impossibility. This refers to a situation where, although there remains on paper a chance that something could occur, its probability is so low and the odds against it so enormously high that it really cannot be admitted as a possibility in any rational argument. Practically speaking, it's impossible. And it doesn't take much to get there. Suppose we have a 50-piece children's puzzle. You know these puzzles you get at Walmart? 50 pieces, right? Not a big deal. A 50-piece children's puzzle. Now, for the puzzle to come together correctly, each piece needs to be in the proper place, so we need a sequence, right? What is the probability that we can dump the pieces on the floor and that they will all fall together in exactly the right locations? Well, to get that, we need to figure out the factorial of 50. Now remember, to get 50, we go 50 times 49 times 48, etc. Now this comes out to 3.04 times 10 to the 64th power. Now that's some seriously long odds. How long is that? Well, that means 3.04 times 10 with 64 zeros on the end. Maybe roughly equivalent or maybe a little bigger than the number of atoms in the universe. Now, some might object that because there's still a chance, granted it's a 1 in 3.04 times 10 to the 64th chance, we cannot call this impossible. Per our examples of the lightning strike and winning the lottery, even remote odds can be realized. But, my friends, we really need to understand the massive distinction between, say, 1 in 258 million, the odds of winning the jackpot, and 1 in 3.04 times 10 to the 64th. I mean, it's a huge, vast distinction. And as we move into probabilities where the odds against something start to range into exponents, we run up against a curve of impossibility such that it becomes logically meaningless to argue against. Like, even theoretically, there's a remote mathematical odds that I could run into a solid brick wall and pass through it by virtue of quantum tunneling, but we know it's never going to happen. I can walk into that brick wall for all eternity and never go through it. It's impossible. These are conditions of statistical impossibility. This really becomes fascinating when we think about the complexity and the order of the universe. Atheists often quip that the Christian defense of God's design in the universe boils down to, well, the universe is way too complicated, so God must have done it. It must have a creator just because it's complicated. This is an oversimplified argument. The universe is extremely complex, to be sure, and I and many others do think that evidence of design is visible in this complexity, but just because something is complicated doesn't mean that it needs intelligence to create, but rather we're looking at something called specified complexity. When something is simply complex, that means it's intricate. But specified complexity is when we see a pattern that is both complex, but also displays a large amount of independently specified information, which is defined as having a very low probability of occurrence. In other words, to put it more simply, there's necessity of a very specific pattern of complexity that occurs. A classic example of this is in genetics, where our individual genes must be arranged in very specific patterns. Every gene needs to be located in a specific place for them to function properly. The configuration is not just intricate, but it's specified. Now remember our 50-piece puzzle and the odds against dumping it on the floor and finding all the pieces in the correct location on the first try? One of the very simplest organisms known to man is called the Mycoplasma genitalium. It's a tiny parasitic bacterium that lives on cells within the human urinary tract. Forget single-celled organisms. This thing is so tiny that it lives on the cells. It's the smallest known free-living organism. Now, the Mycoplasma genitalium has 525 genes. So in this organism, all 525 genes must be arranged in a particular genetic sequence. What are the odds of this happening by chance? Now, as a matter of fact, according to the online factorial calculator, you can go online on Google, they have a factorial calculator where you can do big problems like this. The probability of these genes being arranged this way by chance is 6.89 times 10 to the 1,201st power. Yes, that means multiplied by 10 with 1,201 zeros after it. The odds against these 525 genes coming together on their own in this specified pattern are so absurdly gigantic that it's a clear case of statistical impossibility. In fact, if you just punch this into Google's regular math calculator, if you do 525 factorial, the answer will come back, it'll say infinity. You have to go on the special factorial calculator to get Google to calculate this correctly. I'm not pulling this out of thin air, by the way. There was a great article in The Atlantic some years ago entitled, "To model the simplest microbe in the world, you need 128 computers." You can look this article up. It was by Alexis Madrigal, and it's all about the Mycoplasma genitalium. It describes how researchers needed a cluster of 128 computers running for 9 to 10 hours to just generate the data on the 25 categories of molecules involved in the cell's life cycle processes for the world's simplest microbe. So, obviously, this thing exists, but the question is the possibility that it could come into being randomly with an unguided process with no intelligence. The odds are so remote as to constitute almost an infinite possibility. And this is just looking at the components necessary for the simplest free-living genomic organism known to man. When you go up even to something still relatively small like the E. coli bacteria, the E. coli has 4,288 genes. One can imagine the difficulties we would be immersed in trying to explain a materialist, unguided development of something like even the most basic light-receptive eye, let alone even the simplest brain. Now, to make this argument even more plainly, the odds become much more remote when we realize that there's no cumulative increase in probability. No cumulative increase. What do I mean by this? Let's go back to elementary school math when we first learned probability. We are taught that in basic math, when you flip a coin, the fact that you get heads 2 or 3 times in a row does not mean there is any greater chance of getting it the next time. Even if you flip heads 1,000,000 times in a row, the probability of getting heads the 1,000,000th and first time is still 50-50. That is, your previous outcomes don't affect your future outcomes. So what does this mean? Just this, that if you shake that 50-piece puzzle box once every second for 100,000 years in the vain hope of getting the pieces to come together on their own, your probability of getting it to happen after 100,000 years is just as remote as when you first started. This is important because there is a materialist fallacy that anything is possible if we give it enough time, that an occurrence which logic and mathematics tell us is impossible at any one time suddenly becomes possible if we stretch the time frame out millions or billions of years. We know it's practically impossible for me to shake the puzzle together on the first try, but if I do it for 1,000,000 years, somehow that great expanse of time makes it more likely. But since there's really no cumulative increase in probability over time, there's no reason why this should be so. A probability of 6.89 times 10 to the 1,201st power remains just that, whether we are on attempt 1 or on attempt 10 million. Now, to wrap this up, biologically speaking, I know this strays into other issues like irreducible complexity and things like that people talk about. Maybe we'll discuss these things in further programs. But the point is, as Metaxas points out in this article, when we start getting to the point where a planet must contain all 200 known parameters for supporting life in just the right measures, the probability that such a planet could ever exist anywhere approaches statistical impossibility. And this includes our own planet. Are you looking for miracles? Well, my friend, the existence of life on this planet is the biggest miracle. Something that science increasingly confirms could not have just happened. Now, obviously, we do have all these marvelous things. I'm not arguing that these things can't happen or that they can't develop, but I am saying that when we say they developed randomly, without any direction, without any intelligence, I mean, to believe that takes a bigger stretch, a bigger leap of faith than any proposition of the Christian religion. So it's some fascinating stuff to contemplate. I hope the math wasn't too much for you. But if you don't believe me, hop on the Google calculator and start typing in factorials, and you'll see how big these probabilities can get. So I hope I've sufficiently dizzied your mind for the day and given you something to contemplate. Our God is a great God, great and mighty, worthy to be praised. Until next time, this has been Faith Matters with Phillip Campbell. May the Lord bless you and keep you. May the Lord make his face to shine upon you and be gracious to you. The Lord lift up his countenance upon you and give you peace. God bless you.